Solving quadratic inequalities in one variable. So an inequality means then you're going to have less than and greater than signs. So if you look at our function for ax squared plus bx plus c, we have one variable, which is x. A, b, and c are all constant values, so they're a number. If we look at our chart, the critical values are our x-intercepts. So that's our x1 and our x2 right here. Those are our critical values. When we make a number line for this, we can represent inequalities on a number line. So if I wanted an answer that was a negative number, so less than 0, we would want all of the values from here. So if we represented this on a number line, we'd have our 0, we'd have x1, we'd have x2. Anything between these numbers, right here, not including x1 and x2, so when we don't include them, we do a circle that's not filled in. Anything in between here will be less than 0. So we know that this will be the same as ax squared plus bx plus c less than 0. If we do it again, now we want to know all of our values that are greater than, so we want everything that's above. So all of this is positive numbers on our graph. So we know that not including x1 and x2, it's everything on the outside. So these values would be ax squared plus bx plus c is greater than 0. And if we wanted to know when it equals 0, that would just be these exact points will be 0. So we put circles on our x1 and our x2, so that's when ax squared plus bx plus c equals 0. So those are all of the different points on the graph. The important thing to remember is that when you're including your x values, that you fill in your circle, and when you're not including them, you leave an open circle. So this orange one will satisfy anything where you want your answer to be a positive answer. The blue one will satisfy when you want to find a negative answer, and the green one will be when you want it to equal 0. For example 1, use the given graph to write the solution for each quadratic inequality. Represent the solution on a number line. So we know our critical values are -1 and +2. So we're going to first, let's make a number line. So we have -1, 0, 1, +2. Now we want to find the answer greater than 0. So we want to find all the values above 0. So we know it's going to be not including -1 and 2, but above them. So this would be our number line for our first values. So we know that x has to be greater than -1 or less than -1, sorry. So anything less than -1 and anything greater than 2 for all the real elements. And if you want to put it in set notation, you can. X such that, that's what the line means, x is less than -1 or x is greater than 2 for all x that are real numbers. The second one, the only thing that's going to be different is now it's greater than or equal to. So it could also include this 0. So when we draw it on our number line, we fill in the circle. So it's the 0 and everything greater than. So for our answer, it would be x such that x is less than or equal to -1, or x is greater than or equal to 2 for all the real numbers. For x squared minus x minus 2 is less than 0, we want to find all of our values less. So when we do it on our number line, we want to know not including -1 and 2, but everything in between. So it'll be x such that so we have boundaries now. So we go -1 is less than x, which is less than 2 for all x are elements of the real numbers. So whenever you have the middle one, just do your first value and your last value, less than x. For the second one, for D, we want to include our critical values. So this one will be the same thing, except we will fill in our circles. So we have x such that -1 is less than or equal to x, which is less than or equal to 2 for all the real numbers. And for x squared minus x minus 2 equals 0, we know that it's this point and this point when it equals 0, so x equals -1 or x equals 2. And it was on a number line, but you would just circle those points. General form of a quadratic inequality in one variable. So one variable means that your ax squared plus bx plus c is all on your left side and everything else is put onto your right side, which would be 0. So when you're solving an inequality, if you have 3x squared plus 2x is less than 1, we can do this by putting it onto a timeline and solving for our answer. So what we're going to do first is we're going to put it into general form. So to do that, we're going to have to subtract 1 from both sides. So 3x squared plus 2x minus 1 is less than 0. Now we need to find the critical values, so that means we have to factor it and find our x-intercepts. So we need two numbers that add up to 2 and multiply to get -3, and they should be 3 and -1. So we have 3x squared plus 3x minus 1 is less than 0. Split it into two groups, and we have 3x and -1. So we have 3x, x plus 1, minus 1, x plus 1. So our factored two binomials are x plus 1 and 3x minus 1. So that means that our critical values will be when x plus 1 equals 0 and when 3x minus 1 equals 0. So x equals -1 or x equals 1/3. So these are our critical values. Now to put this on a number line, we write in our critical values. So -1, 0, 1, and 1/3 would be not there. Right about there. So we want to find when it's less than 0. So we want to find our middle bounds. And it's not greater than or equal to, or less than or equal to. So we have a circle, open circle, and we want everything in between. So we know that our answer will be x such that -1 is less than x, which is less than 1/3 for all the real numbers. Now, once you find your answer, it's important to test to see if it works. So you have to choose a test point. So a test point is a point from an interval of an inequality that satisfies the equation. So we want to check all of our intervals. This is your first interval, this is the second interval, and this is the third interval. So we're going to test the first interval. So we're going to test x is less than -1. So choose a point that's less than -1. So let's go x equals 2. So we're going to substitute this into our original equation to see if it satisfies. And if our answer is right with our timeline, we know that it won't satisfy because it's not including those areas. So 3 times 2 squared plus 2 times 2 negative is less than 1. 2 times 2 is 4, times 3 is 12, minus 2 times 2 is 4. So 8 is less than 1. This does not satisfy. So we know for sure that this interval right here doesn't work. Now we're going to test our second interval. So we're going to test -1 is less than x, which is less than 1/3. So let's choose x to be 0 because it falls between -1 and 1/3. And from our answer on the timeline, we know that this should satisfy our equation. So we're going to test that. So 3 times 0 squared plus 2 times 0 is less than 1. 0 is less than 1. That is correct. So we know this interval works. And last is to test when x is greater than 1/3. So let's choose x to be 1. So 3 times 1 squared plus 2 times 1 is less than 1. 3 times 1 is 3, plus 2 is less than 1. 5 is not less than 1, so this does not satisfy. So this doesn't work. So we know absolutely 100% sure that any point between -1 and 1/3 will satisfy this inequality.